Okay, today's notes is going to be on 4.2 angle relationships in triangles. We've already discussed this, the triangle, the angles inside a triangle and how they add up to 180 degrees. That's what the triangle sum theorem states. If you have a triangle, the three angles inside a triangle will sum to 180 degrees. So let's just say I have a triangle and my three angles I'm saying are A, angle B, and angle C. If you add A plus B plus C, it will be 180 degrees. We're going to watch this short little clip here to see how this theorem is actually proved. Okay, so you're going to watch this theorem real quickly. Okay, so what we're doing here is we're going to prove the triangle sum theorem. As you see on the drawing, we have a line at the top and a line at the bottom. Those lines there are parallel. And at the top we have three angles, A, C, and B. They're forming a line, those three angles together. So that means A plus C plus B will equal 180. Now in the triangle, C, X, and Y, okay, should add up to 180 based on the theorem here, which is if you have the parallel lines, angle A and angle X are alternate interior angles, and so they're equal. And angle B and Y are also alternate interior angles, so they're equal. So you can replace X with A and B with Y, and thus X plus Y plus C will add up to 180 degrees. And that's how the triangle sum theorem is created. Okay, so that was how the triangle sum theorem was proved. Now let's apply it to example number 1. So in example number 1, we have to find the values of x, y, and z. So the first thing I want to do is I want to look at this triangle here. I have two angles and I'm missing one. Well, I know all three will add up to 180 degrees, so I can go x plus 15 plus, and that box means 90 degrees, equals 180. Combining these, that gives me 105. I'll then subtract 105 from 180 and get 75 for x. So x is 75. Now, you can see these two triangles here, they're connected, okay? And what's happening here is these two intersecting lines are creating two vertical angles, the y and the 15. So vertical angles we always know are equal, so thus y must be equal to 15. So y equals 15 by vertical angles. So this is 15. And then I can find z by doing the same method again, adding them all up to 180. So I can add z plus 15 plus 100 equals 180. So 100 plus 15 is 115. And then I subtract 115, which gives me 65. And that's how we find the missing angles in a triangle using the triangle sum theorem. Okay, moving on to a special kind of triangle, equilateral triangle. You've already learned that an equilateral triangle has three equal sides and three equal angles. All the angles we learned would be 60 degrees. And I'm putting that slash marks in there to indicate that those three sides are equal. So equilateral triangles are 3 equal sides and 3 equal angles. Right triangles, well, right triangles are triangles that have one right angle. Okay, and we learned also that if this is a right angle, okay, these two angles here, call this x and this y, x and y will have to be acute because the three angles here will add up to 180 degrees. You can't have anything more than 90 degrees in either x or y, and it'll be more than 180. So therefore x and y have to be acute. So angle x and angle y are acute angles. Okay, so that's, you should always know when you have a right triangle, the other two angles will be acute. Okay, so let's move on to example 2. So in example number 2, we have to find the value of x. Well, we know two angles, we're missing one, we'll do the triangle sum theorem. So we'll do x plus 90 plus 27 equals 180. So 90 plus 27 is 117. And when we subtract 117, we're going to get 63. That's how we find example 2. The next theorem we're going to talk about is the exterior angle and remote interior angle theorem. Well, in a triangle, there's 3 interior angles. We've already talked about that with the triangle sum theorem on the previous page. However, there is also 3 exterior angles of a triangle. So, say we have a triangle here, and we'll label these interior angles as A, B, and C. So, A, B, and C are interior angles. Okay. And each interior angle has an exterior angle. So we'll call this E, F, and G. So E, F, and G are exterior angles. So we know that the 3 interior angles A, B, and C, when you add them together, would be 180. But there's particular relationships between the exterior and the interior relationships, angles. Well, for instance, you should notice that angle A and angle E here are forming a linear pair. So these two angles will add up to 180 degrees every time. So will these, and so will B and G. Now, there's also another relationship that happens between these. So for instance, say we have angle F. It has a particular relationship with the 2 remote interior angles. The word remote means isolated, away from. So A and B are 2 interior angles that are away from the exterior angle F. So we can say that angle F is an exterior angle, and its remote interior angles are angle A, and angle B. And every exterior angle has 2 remote interior angles. So for instance, look at angle E. What would be its 2 remote interior angles? The 2 interior angles that are not next to angle E. It would be angle B and angle C. And lastly, for angle G, what would be the 2 remote interior angles? It would be angle A and angle C. So there's a particular relationship among them. So I want to prove that right now. So I'm going to do this on a separate sheet of paper here. to prove that to you, the relationship. So for instance, say I have a triangle here. And I give you the two remote interior angles. Say they are 60 degrees and 40 degrees. Okay, there's a particular relationship between these two angles and the exterior angle that you're going to find out. Well, all three angles here, the inside, we'll call this angle C here, these three angles will add up to 180. So I know that it's 60 plus 40 plus angle C will equal 180. So angle C must be 80 degrees. So this is 80 degrees. So they're forming, the E and this interior angle right here are forming a linear pair. So E must measure 100 degrees. Now, going back to our original triangle here, what was the relationship that you think could be the case between the 16 and 40 and the exterior angle that's 100? Well, if you add 60 plus 40, that gives you 100. So that's what the exterior angle is always equal to. The exterior angle is always equal to the sum of the two remote interior angles. So if you add these two together, it will equal the exterior angle. Okay, so let's go back to our notes here. The exterior angle theorem states that the exterior angle in a triangle is equal to the sum of the two remote interior angles. So again, the exterior angle is equal to the sum of the two remote interior angles. So we can apply that in example number 3. In example number 3, we've got our exterior angle, the 114. And these two angles right here, these are your remote interior. So we know if we add the remote interior together, it will equal the exterior angle. So we know that 114 must equal y plus 38. So solving this here, when I take minus 38 on both sides, you're going to get 78. $76. And that's how we get y. So right now on a separate sheet of paper, I'm going to have you try one of these problems yourself that I'm going to give you. So go ahead and solve for x there. Okay, so the solution to this problem is taking the exterior angle and equaling it to the sum of the two remote interior angles. So it's going to be 110 equals x plus 72. So solving this, I would subtract 72 on both sides, and I would get 38. Okay, so let's go back to the next example. So in example 4, we have to find x. So again, we have the exterior angle. We have the two remote interior angles. So we know the relationship is that the exterior angle will equal the sum of the two remote interior angles. So we're going to do that. So we're going to take again 126 and equal it to 5x plus 17 plus 6x minus 1. So when I combine 5x and 6x, I get 11x. 17 and negative 1 is positive 16. That will equal 126. I'll then subtract 16 on both sides, which gives me 110 equals 11x. And lastly, divide by 11, which will give me 10. So x equals 10. And let's move on to example 5. In example 5, I'm going to give you a minute there to try to find the solution to that. So you're going to solve for x, okay, and then you're going to find the measure of angle DAC. DAC. Okay, so find the measure of DAC after you solve for x. Okay, go ahead. So again, we're going to go over this solution here. So this is their exterior angle, and these are your two remote interior. So what you're going to do is you can take your exterior, the 8x minus 15, and equal it to the sum of the two remote interiors, which is x plus 48. And then we're going to solve. So get variables on one side, numbers to the other, like a minus x here. So that gives me 7x minus 15 equals 48. I'll then add 15 on both sides. So 7x equals 63. And then lastly, divide by 7. So x is 9. Now that I know what x is, what I want to do is substitute back into angle DAC, which is represented by 8x minus 15. So angle DAC will equal 8 times 9 minus 15. Well, 8 times 9 is 72, and 72 minus 15 is going to be 57 for the measure. Obviously, you can tell that this is not drawn accurately to scale because DAC should be obtuse, but it's not. So again, things are not always drawn to scale, so don't assume that the diagram is correct. Okay, moving on to the last theorem here, the third angle theorem. The third angle theorem states, what is really talking about? It's talking about when you have two triangles that have two pairs of congruent angles, then the third pair will be congruent. So as a drawing here, and then I'll prove it. Say we have triangle ABC and triangle DEF, and A is 40, D is 40, B is 60, E is 60. This is going to say, therefore, angle C is congruent to angle F. And that's got to make sense because the triangle sum theorem will prove it. So for instance, if this is 40 and this is 60, all three angles here must add up to 180 degrees. So 40 plus 60 is 100. 100 minus 180 gives you 80. So this would be 80. And 40, 60 is 100. This would be 80 as well. So if you have two pairs of congruent angles, the third pair will always be congruent because it has to be based on the triangle sum theorem. And that's the third angle theorem. Okay, and so let's apply that in example 6. So in example 6, we have to find x, and then angle P, and then angle S. Now, what we see here is that we know that angle M is congruent to R. Okay, so angle M is equal to angle R, as well as N is congruent to T because of the two arcs there. And so two pairs of angles are congruent, therefore angle P will be equal to angle S. So all I gotta do is set angle P, which is 2x squared, equal to angle P, S. Let me try. I'd set angle P equal to angle S, which is 2x squared equal to 4x squared minus 32. And then solving this here, I can minus 4x squared on both sides, which will give me negative 2x squared equals negative 32. I then want to first divide both sides by negative 2, which would give me x squared equals positive 16, because when you divide two negatives, you get a positive, and take the square root of 16, which was 4. So there's my x value. It's 4. Now I want to find angle P and S. Well, I just substitute in 2 times 4 squared. So 4 squared is 16. So it's 2 times 16, which is 32. So that's what angle P is. And I already know S is equal to P, so this is also 32. And that's the end of this lesson. Okay, so we're going to do a few extra practice problems. I just want to make sure that you understand what you need to be doing here to make sure that you don't have any trouble on your work that you're going to do. So, for our first extra problem on a separate sheet of paper, we're going to draw a triangle here. And let's say this is 2x plus 5. This is 3x plus 25. And this is 5x. And so what we're going to do is solve for x and then find each angle, A, B, and C. Well, it's a triangle. When you have the three angles inside, that means they will add up to 180 degrees. So we know that 3x plus 25 plus 2x plus 5 plus 5x will equal 180 degrees. So when you solve this here, 3x, 2x, and 5x, that gives me 10x. 25 and 5 gives me 30. So 10x will equal 150. So x is 15. And now that I know x, I can substitute back in to find each angle. So angle A would equal 3 times 15, 45, plus 25 is 70. Angle B would be 2 times 15, which is 30, plus 5 is 35. And angle C would equal 75. And that's one of the extra problems I want you to try. The next one is to practice knowing the relationship, finding all the exterior angles. Okay, so for instance, say I give you this is 100. Say I give you this is 40. Just knowing that, you can find X, Y, Z, and W, we'll call them. So we'll see how the relationships work here. For instance, remember I said that the exterior and interior, they have some direct relationships. The exterior angle is equal to the sum of the two remote interior angles, so you should know this is 60. But in addition to that, you know that they form linear pairs here, the exterior with the interior. So I know X will have to be 80 because 100 plus 80 gives me 180 degrees. So this is 80. And we already said this would be 60. And another way you could have verified it would be 60 is because these three angles will have to add up to 180 because they're inside a triangle. So 60 plus 40 plus 80 is 180. So that's why this is 60. Z will be forming a linear pair right here, so it means it would be 120. Another way to verify it is this should equal the two remote interior angles added together, so 80 plus 40, which is 120. And then lastly, to find this angle here, again forms a linear pair, so it should be 140. Or again, verify it with the two remote interior angles. 80 plus 60 is 140. Okay, so again, knowing those relationships there will be key for you to be successful in this section.